The sarin possesses an extraordinary capability. It can transform dust into metal, yet the instant that metal forms it vanishes. This is not merely a chemical reaction, it is part of an advanced experiment inside a nuclear reactor. Within this reactor, a single metallic particle with 79 protons briefly came into existence. In an instant, it was transformed into a subatomic atom. But why are we attempting to convert dust into metal? The answer lies in a purpose greater than technology itself. It is to contribute to the life and evolution of the universe. Even in ancient times, the Shemidans experimented with stones to measure their value according to their old traditions. Discovering the formula to transform stone into metal could expand humanity across the cosmos. The sarin can convert up to 86 billion atoms into metal each year. That might sound enormous, yet it is insignificant. It is not even the size of a microbe. Only now do we begin to grasp the vast number of atoms in the universe. This raises a profound question: how were all these atoms created? A single microbe contains more than 100 billion atoms. Classical chemistry has failed to produce true metal. It relies solely on chemical processes. Sarin succeeded because it transcended chemistry for the sake of the great bar. The history of dust has been rewritten into metal. This new form is untouchable, unsellable, invisible, and uncontrollable. The cosmos showed us the way to become metal, yet it forbade us from using the substance itself. Whenever we discover something remarkable, nature stands before us. It seems to say, you may understand it and recreate it, but you shall never use it. When the sarin's atom reached 99% of the speed of light, it shattered by generating 3 protons. Sarin transformed into a metal with 79 protons. The reaction unleashed an overwhelming burst of energy. The metal atom absorbed the energy and exploded instantly. Through this process, matter can indeed be created, but it lasts only for a few fleeting seconds. Producing metal in this way is extraordinary, yet to create a single kilogram would take thousands of years. It would also cost thousands of dollars. The goal is not profit. The objective is to recreate the most delicate moment in history, the moment of the cosmos Big Bang. When atoms merge, they do not collapse immediately at first. They compress, then ignite into a colossal fire, one hotter than a comet and hotter than anything known in the universe, reaching a trillion degrees Celsius. At such temperatures, matter cannot endure. Protons and neutrons burst apart, forming a dense, chaotic mass. This event is unnatural and occurs only during a great explosion. It is what we call quark. Plasma matter exists in its purest state before it becomes an atom. This plasma phase lasts less than 10 to the power of minus 23 seconds. It then escapes into the vacuum of space. Suddenly it solidifies and cools, mirroring the moment of the great cosmic explosion. From this event emerged the first hydrogen and helium. These elements later fused within stars, creating heavier elements like iron, platinum, oxygen, and calcium. When stars died, they scattered these elements across the cosmos. From their remnants we were born. We are the fragile descendants of stars deep within the core. Scientists repeated a similar process. Something extraordinary happened. A quark, which normally cannot exist alone, was momentarily freed at a temperature of 2 trillion degrees. Quarks behaved independently, forming a strange fluid-like soup. As the quark plasma cooled, it absorbed vast amounts of energy from surrounding atoms. It then restructured itself. The quarks followed exact physical laws balancing temperature, pressure, and ratio in perfect quantum symmetry. Each quark carries a memory of how it should behave even when cooled to absolute zero. It remains connected to this memory. This all occurs in less than the time it takes for a photon to move. We can create these phenomena but cannot preserve them. Humanity can now produce antimatter but cannot store it safely. If a gram of antimatter contacts a gram of regular matter, the reaction releases energy equivalent to thousands of atomic explosions. This is according to Einstein's equation E equals mc squared. It is the purest and most powerful energy in the universe. Experiments have shown that colliding hydrogen atoms produces monstrous waves of gamma radiation. Scientists use magnetic fields to contain these antimatter particles. Merging them transforms them into pure energy. These experiments raise incredible questions. Does antimatter respond to gravity the same way as matter? Does it fall down or rise upward in Earth's gravity? Can antimatter pass through the fabric of space differently than normal matter? Several sources of antimatter have been successfully confined in complex electromagnetic chambers. Observations reveal that gravity affects antimatter as it does matter. It seems as if it understands its surroundings. Researchers have managed to contain antimatter for up to 20 minutes, a monumental achievement in scientific history. To produce antimatter, scientists used an entirely new approach compared to conventional atoms. While traditional atoms are constructed by combining heavy metallic elements, antimatter is created through absorption and collision of protons in controlled environments. Yet the final haunting question remains: are these experiments dangerous? Could they have unforeseen effects on Earth stability? Is there a chance that one of these reactions might spiral out of control? And worst of all, if a black hole were to form, what would happen next? Would Earth vanish into emptiness? What would become of us then?